Have you ever gotten lost in a sea of Boolean algebra?
I mean, it can get so messy, right? Well, what if I told you there's a visual shortcut, a way to literally see the answer instead of grinding through the math? We're going to dive into an amazing tool that does just that.
So, really think about this for a second. What if you could solve some really complex algebra just by looking at it? Not by crunching numbers or following rules, but just by recognizing a picture. Sounds a little like magic, I know, but that's the big idea behind what we're talking about today. Okay, take a look at this thing. It's a pretty typical Boolean expression, right? A standard sum of products function. And sure, we could simplify this the old-fashioned way, factoring, applying a bunch of Boolean laws, but let's be honest, it's not exactly intuitive, is it? It feels like there's gotta be a better way.
Well, there is a better way, and it's called the Karnaugh map, or as everyone calls it, the K-Map. This thing is so cool. It basically turns all that messy algebra into simple shapes. It makes simplifying logic feel less like math and more like solving a puzzle.
You know, when you get right down to it, a K-map isn't some brand new, crazy concept. It's really just a truth table that's been cleverly rearranged. We're taking that long, boring list of ones and zeros, and we're organizing it into a nice, neat little grid.
So to put a finer point on it, a Karnaugh map is a visual way to simplify Boolean expressions. And the real genius behind it, the secret sauce, is that where you put something in the grid actually matters. The position of each little box is key, and that's where all the power comes from.
And you can see that direct link right here. See? Every single row in the truth table, what we call a minterm, has its own special spot in the K-map. So minterm 0, where A and B are both 0, that goes in the top left cell. Minterm 1, bottom left, and so on. It's a perfect one-to-one match. Everything has its place.
All right, so now that we get the layout, let's actually build one. We're going to take our function and plot it right onto the map, step by step. Okay, let's start with row 1. A is 0, B is 0, and our output, F, is 1. So where does that go on our K-map? We find the cell for A equals 0 and B equals 0. That's the top left one. And we just pop a 1 in there. Easy.
Next row. This time, A is 0 and B is 1. The output is a 1 again. So we find the spot for A equals 0, B equals 1, which is the bottom left cell, and bam, another 1 goes right there.
Okay, on to row 3. A is 1, B is 0. This time the output is a 0. So we find its home, the top right cell, and we put in a 0. Now, you could just leave these blank, but for today, we'll write the zeros in just to be super clear.
And finally, the last row. A and B are both 1, and the output is 1. That maps perfectly to our last empty spot, the bottom right cell. And there you have it. Our truth table is now a fully populated K-map. Now it's ready for the real magic.
Okay, get ready because this is the aha moment. We've put all our ones and zeros in their places. Now we're going to connect the dots. And in doing so, we're going to uncover the simple logic that was hiding in that messy equation. This is where the K-map really shows its stuff.
So here's the secret. The whole game is about finding ones that are next to each other and drawing circles around them. But there's one big rule. Your groups have to be a power of 2. So you're looking for groups of 1, 2, 4, 8. You get the idea.
Let's find our first group. See this vertical pair of 1s right here in the left column? Okay, let's look closely at what's happening inside this group. As we go from the top one to the bottom one, what changes? Well, B goes from 0 to 1. See that? Since B changes inside our group, we get to completely eliminate it. Poof, it's gone. The only thing that stays the same is A, which is always 0. So that whole group simplifies down to just A prime.
Okay, let's hunt for another one. How about this horizontal pair along the bottom? Let's do the same thing. As we move from left to right inside this group, what happens? A goes from 0 to 1. So since A is the one that changes, we get to toss it out. What stays constant? B, which is always 1. So that entire group simplifies to just B. And now for the big finale. We just put our pieces together. That first group gave us A prime, the second group gave us B. So our final, super simplified function is F equals A prime or B. Just look at that. That complicated expression on the left that would have taken a bunch of algebraic steps, we just solved it in seconds, just by drawing 2 circles. How cool is that?
You know, once you do this a few times, you start to see the same patterns over and over again. It becomes second nature. So let's do a quick lightning round of the most common ones, so you can start solving these things in a flash.
Pattern number 1. If you see the whole left column is full of ones, don't even think. Just write down A prime. It's always A prime, because B is guaranteed to change.
And you guessed it, the opposite is true. The entire right column is full of ones. That's your visual shortcut for the term A. Simple as that.
Okay, let's flip it. How about the entire top row being filled with ones? Yep, that's an instant simplification to B prime. Why? Because A is the variable that's changing. And for our last shortcut, the full bottom row. You know where this is going. That group always simplifies to just B. If you can memorize these 4 shapes, you'll be solving these K-maps like a pro in no time.
So if there's just one thing you remember from all this, make it this golden rule. When you group ones together, you get to eliminate the variable that changes. And here's a pro tip. Always try to make the biggest groups you can. The bigger the group, the more variables you get to eliminate, and the simpler your logic gets. It's all about making the biggest circles possible.
It's a pretty powerful idea when you think about it, isn't it? A simple little grid can outsmart complex algebra just by turning it into a picture puzzle. It really makes you wonder, what other amazing visual shortcuts are out there, hiding in plain sight, just waiting for us to find them?
Thanks for watching. See you next time.